Yeah, my name is Ody. I'm a software engineer in Nigeria. I currently work for a company called Device Connect, based in Basel, Switzerland. And yeah, I build software for a living, mostly in F#. And yeah, so let's jump right in, I guess. Okay, so today I'm going to be talking about building full stack web applications with the Safe Stack, right? And yeah, so this is me, software engineer since 2011, YouTube content creator. So I have a YouTube website where I teach software engineering. I mostly focus on .NET, Java, and JavaScript. So yeah, the goals for this talk, well, this is not going to be another Safe Stack, deep dive introduction. This is just going to be mainly high level, and we're just going to focus on just the main architectural ideas. There is some coding involved, but the coding is just kept to a minimum. So yeah, so what is Safe Stack? What Safe Stack is a full web stack, right? F#. So it's F# end to end. It's functional first, meaning that the concept, the architecture is mostly functional. Uses the functional paradigm of using composition, right, over things like inheritance and stuff like that. And you also get strong type safety as well, both on the client and on the server. So SAFE actually is an acronym which stands for the S stands for either Suave or Saturn, which are like web frameworks, A for Azure or AWS, F for Fable or Elmish, F for Fable, and E for Elmish. Even though that's what the acronym means, you can mix and match within between any of these components. It's not compulsory. You have to, stick to this. It's there's a lot of embracing going on. So it's whatever tools or whatever technology makes you happy, it's embraced. As long as it is fully F# end to end, then it's Safe Stack essentially. So this is an idea of what it looks like. So on the right hand side, you have your browser, which is your client, right? So it will be running Fable with Elmish. And on your back end, you have your server. So it could be running either Saturn or Giraffe, which is the web framework that Saturn sits on top, or just ASP.NET Core. And it could be hosted with either Docker or Kubernetes or in Azure or AWS. It doesn't really matter. That's the main idea behind the Safe Stack, end-to-end F# coding. So yeah, first we're going to look at the server aspect of it, and we're going to look at how does F# fit into the whole server ecosystem. Yeah, so for the server, we'll be using something like .NET, right? So it's a very, very old framework. It was launched in 2002. It was rewritten in 2016 as .NET Core to make it cross-platform and compatible with Linux and Mac and all of that good stuff. It was also made fully open source, so all the source code is on GitHub. It's open collaboration, so pull requests are accepted and stuff like that. And it's currently seeing a renaissance, right? So most people who probably left .NET are starting to come back, and there's a lot of resurgence going on, which is quite nice to see. And F# is a part of that renaissance. So F# is an integral part of .NET. It ships with the .NET SDK out of the box, and it reuses the same high performance libraries and tools. So it's built on a very solid base of libraries, tools, and so on and so forth, right? And yeah, so the F# stack on .NET currently looks something like this. You have your .NET framework sitting at the bottom, and then you now have ASP.NET on top of that. So ASP.NET is the web framework that most of .NET uses. It includes a lot of libraries that you use for .NET and so on and so forth. Giraffe sits on top of that, and then Saturn sits on top of Giraffe. So that's how it's laid out in terms of hierarchy. So yeah, what's ASP.NET? ASP.NET is a high-performance .NET web framework. The architecture consists of middlewares that so a bunch of middleware that are assembled together to form a pipeline. And there are services that you use to configure those middleware, right? And all of that runs in a production-ready web server. So the name of the web server is called Kestrel. So Kestrel is what is deployed inside your application. So when your application boots up, when you're executable, when you launch your executable, it launches Kestrel, and then Kestrel now, kicks off the whole ASP.NET pipeline. So this is what the ASP.NET pipeline looks like. You have your request coming in, and then you can assemble a bunch of middleware. So for example, there could be HTTPS middleware that's responsible for redirecting. So if a request comes in, it's responsible for redirecting the users to HTTPS. I think, but before I even talk about that, I think it's important to even explain what middleware is. So a middleware is just a component that receives a request and generates a response. But as part of receiving that request, it has two options. It can either hand over the request to the next component in the middleware, or it can respond to the middleware directly. It could also transform the request as well. So there are some middleware that their job is just to transform or add extra details to the request and stuff like that. So like, for example, in the case of the HTTPS middleware, all it's simply going to do is take a request, look at the URL. If the URL has HTTP in it, then it will just return a 304 redirect to the HTTPS endpoint. Quite straightforward and simple. So, but the reason I'm showing this is because all the middleware is common to all frameworks that are running on top of ASP.NET. So you have a whole bunch of middleware for virtually anything you want. So you have middleware for authentication, so things like JWT, cookie authentication, or CORS, which is cross-origin resource sharing. You have middleware for that as well. And then you can have your web server as a middleware too. And each of these middleware is configured by injecting services. The services determine how that middleware is going to behave. So for example, if I'm building a web API, if I'm building an API, right, I could just inject a JWT configure my authentication middleware to use JWT. But if I was building like a regular website, I could just configure that to use cookies instead. Okay. So, so that now brings us to Giraffe. If you remember from our slides behind, we talked about Giraffe sitting on top of ASP.NET, right? So, yeah, if you look at this pipeline, you can see that Giraffe is the last middleware in this component. So, what Giraffe is Giraffe is simply a web framework, an F# web framework that sits on top of ASP.NET Core middleware. It's actually an ASP.NET Core middleware, and as a result, it leverages a lot of the power of ASP.NET, the high performance, and all the middleware that already exists for different kinds of things like gRPC or whatever the case may be. So it's quite cool, and what makes it unique is that it's built upon a functional architecture. Okay, so that now brings us to the functional architecture. Well, if in functional programming, functional architectures are typically like building Legos. So you have a small unit, which could be a function, which is typically a function, and then it gives you ways of assembling those functions together to form more complicated structures or more complicated functions. So in terms of Giraffe, that smallest component would be the HTTP handler, which is similar to a single brick of Lego. And then you combine it in interesting ways to form your web application, right? So the entire web application with routes and checking for get, post, put, delete, and all this kind of stuff. That's what the functional architecture looks like. So talking about the HTTP handler, this is really the smallest building block of a Giraffe web application. So what it is it's made up of three main types. You have the HTTP handler. So let me work my way backwards. It starts with a function HTTP func result, which is just an asynchronous, is a task. An asynchronous, it returns asynchronously either a context or it doesn't return anything, right? That's the HTTP func result. And the HTTP func itself just takes a context and returns, and may or may not return a result asynchronously. And the HTTP handler takes a HTTP func, takes a context, and returns the HTTP func result. You don't have to worry about this is a little bit confusing for people who are new, but if you're used to the framework, it makes perfect sense. But all you just need to know is that this is what the shape of any HTTP handler looks like. So you have you have the next HTTP handler in the pipeline, or HTTP func in the pipeline, and you take a HTTP context and the HTTP context has all the information you need from the request. So you can pull out the query parameters, request parameters, HTTP post, whatever you want from it. And then you have the task, which is essentially the body of your HTTP handler. HTTP handlers together, and that's what this is. So this picks between one of these sets of handlers. So this is an array in F#. So this particular handler is combining two handlers. So this one checks for the route. If the route is /ping, then handles it, and then we're combining that with another handler that just returns the text pong together. So this becomes a single handler. And like that as well. So this one is for the default URL. This just listens to the default endpoint / and then generates a HTML file out of it. And this just listens to hello. So this is our say hello handler from here. This is essentially that. So that now when you have /hello, it calls say hello and returns the UI. And then that's it for Giraffe. But the thing is, Saturn, like I said earlier in my previous slides here, Saturn sits on top of Giraffe. So what it is instead of having to manually build HTTP handlers together, which you totally can, is totally fine, you can use a slightly higher level library called Saturn that sits on top of Giraffe. And what it gives you is things like it gives you a simple way to define your routes and the building blocks of your application. It uses a feature in F# called computation expression that allows you to declaratively declare your application. So for example here, we're declaring an application, we specify the error handler, we specify the router, and we can specify the URL, right? It should listen on, add some middleware, and we're done. So this is really, really useful and nice. So yeah, if you want more documentation on ASP.NET Core, on Giraffe, on Saturn, these are the URLs. Okay. And now it's time for a simple demo. Okay, so just give me a moment. Let me change what I'm sharing. There we go. Awesome. So and once you have the .NET SDK, you should be able to say .NET, right? And that just shows us what we can do. We can list the SDKs we currently have and so on and so forth. But here I want to, you can then install a template. So just give me a moment. Okay, so yeah, So here you would first have to install the template using something like this. So that would be .NET New -I Giraffe template, and then you can install the template. But after the template is installed, you should see a .NET New. So when you type .NET New now, you should have the option of creating a new. So if you come all the way here, we have Saturn, we have FABLE. Yeah, sorry, I'm getting lost. You can create a new Giraffe application from there. So here we can just come here, head over to create a project folder, create a temp directory. Let's just call this Lambda Days. And inside this directory, I can say .NET New FABLE, sorry, .NET New Giraffe, right? And this will go ahead and create the Giraffe application for us. And then I can just open that folder in VS Code. That'll be code Giraffe. Sorry, that's not it. That's supposed to be Lambda Days. Lambda Days. Ooh, messed something up. Let me go back to Lambda Days, .NET New Giraffe. That will generate that. I can then open that in code. So let me share that now. There's the page. There we go. Perfect. Sweet. So as you can see, it generates a bunch of stuff, but the important thing I want you to see here is the program.fs, which is the application file, which is the file that has essentially our application. And here, if you look at the bottom, this is the entry point to our main application. This is where the Kestrel is being configured. That's what this web host is. And then there are some functions that just configure some static files and so on and so forth. Don't need to worry about that. All I just need to show you is this. So this is the web application itself. So it's saying it's going to choose from a bunch of handlers, and the first one is the get. So if the request matches the get, you get it will then move over to this second block and checks, does the request match the / route, the default route? If that's the case, it just generates it calls index handler with hello world. So this will say hello world from Giraffe. And if it doesn't exist, it will move on to the next one. So in this one, it's just saying hello, and it can take a parameter from the URL. So let's go ahead and just run this. So if I come here, what I need to do is to say .NET run, and that should launch the app. There we go. It's currently running. Let's just open it in HTTP 5000. Paste that here. Expecting me to. Let me see. I think I'm having some. Okay, there we go. Let me share my screen so you can see that as well. So stop sharing this and share. Where's the web page? Oh, okay. Same.
While you're sharing, Ody, that's halfway.
Yeah, okay.
Halfway reminder.
Okay. There's. Okay. I've seen what I'm looking for. There we go. Wow, that was crazy. So you can see hello world from Lambda Days. That means it's running correctly. All right, let me stop this and let's quickly switch over back to my slides. Here we go. Perfect. Okay, so we've completed the server part. Talked about functional architecture, looked at the documentation, done the demo. So now we're on to the browser aspect as well. F# as part of the JavaScript ecosystem. So yeah, the JavaScript ecosystem started. It was launched with the early web in 2002. It has experienced a renaissance in 2008 due to V8 and the browser wars. In 2009, JavaScript Node.js was created, based on V8 that allowed JavaScript to run on the server, and that now made JavaScript very fast and a respectable language. It has gone through quite a bit of revisions. So it started as ES1, from ES1 to ES6. And then in 2016, they switched over their naming convention from ES16 to ES2020, which means that they name it every single year. And yeah, the libraries and frameworks have been evolving rapidly. If there's anybody that knows anything about the JavaScript ecosystem, is that things move very, very fast. And modern JavaScript today uses transpilers. So even though the browsers and the platforms don't support ES2020, for example, for you to be able to keep up and keep writing like the latest versions of JavaScript, you need some kind of transpiler that can take the original, your upgraded JavaScript and transpile it into something that lower platforms will be able to process. So F# as part of the JavaScript ecosystem, F# on the client side is made possible by FABLE. FABLE is simply a Webpack plugin like LESS or SAS and so on and so forth, like I mentioned earlier. It reuses the same client-side libraries and tools like Webpack. Also, one of the things that Webpack does is things like tree shaking. So what tree shaking does is it looks at the entire code, and any code that doesn't get executed or any library that is included that doesn't get used, it will discard and remove them just to improve performance and reduce download size and things like that. It also supports something like hot module replacement. So what hot module replacement does is it allows you to quickly make changes in your client-side code, and then it will get refreshed in the browser. So as you're making changes, you're getting this live instant feedback, which is really, really good. And it also supports things like minification, obfuscation, etc., or even CSS preprocessors as well. And then you could also use F# as part of WebAssembly. So you can compile F# to WebAssembly and then use it inside your browser using the Bolero project. And yeah, it's really cool. FABLE is also compatible with Node.js, so you could use F# to write server-side Node.js applications as well, which is awesome. But all this is possible because of FABLE. So FABLE is the magic that makes this happen. So what is FABLE? FABLE essentially converts F# to JavaScript. Behind the scenes, it uses the Babel JavaScript transpiler or compiler, and then it shims out .NET APIs. So what it does is, because when you write your F# code, you're targeting native .NET APIs. So it will do one of three things. One is that it will replace the API calls with API calls to JavaScript equivalent. So if you use something like system.datetime, it's going to replace that to a call to the date API, which is cool. Then in some other cases, it just goes ahead and it re-implements some of the JavaScript, some of the missing JavaScript, some of the missing .NET APIs in JavaScript. So something like async or task or whatever, those are re-implemented in in JavaScript with FABLE, and they are stored in a NuGet package. It's called, I think, FABLE Core. That's the name of the not NuGet, npm package. And then it has native .NET libraries and shims for JavaScript API. So from your F#, if you wanted to call like a browser API, it has like libraries that you can use to talk to it, and it's fully compatible with all existing npm packages. So that now brings us to the structure. This is how it works. It takes in F# source code. It compiles that into the abstract syntax tree. So that's the F# syntax tree that says, okay, this is the syntax, this is the understanding of what your program is. And then FABLE looks at that syntax tree, goes ahead to pull in npm packages for those other implementations I told you about. Anything that's targeting the .NET APIs, it pulls in those implementations as NuGet packages. It assembles a proper it assembles a fully fledged abstract syntax tree, and then now handles that, converts that into Babel's abstract syntax tree, and that is now sent to Babel, and then that now generates JavaScript out of it. It's actually quite neat. So yeah, it's at the end of the day, you just get JavaScript out. There's no magic going on. So in terms of configuration, this is how you configure it in your Webpack file. You just add the, of course, you add your Babel core, but you add your FABLE compiler and your FABLE loader. And you can add a few other stuff like React, React DOM, Webpack, and so on and so forth. And then in the package.json, oh, I missed this. So it's flipped actually. This is your package.json with your packages. And this is the your Webpack config. So in your Webpack config, you can specify the entry point as fsproj. Now, the only way it knows how to interpret this fsproj is using the module, right? So this FABLE loader that was installed here, it uses that to generate this rule that says if you see anything of .fs, .fsx, or .fsproj, just call that with the FABLE loader. Then the FABLE loader can kick in. Remember what we said about the pipeline? It can kick in and then convert that to JavaScript. And then the JavaScript will be located here as this bundle.js. That's where it's going to be stored inside the public folder bundle.js. Cool. So demo time. So following the documentation that I showed earlier, right? You install it in a similar way, similar to the way we install the Giraffe template. You install the FABLE template as well. You simply say .NET new FABLE. Say .NET new. You'll see that FABLE is one of the options. That's F# FABLE. It's one of the options already. And I can simply go to, let me move back a little bit. And they'll create the two. And I now say .NET new FABLE. Okay. So when I do this, it generates a bunch of files. So I can now go ahead and open it in VS Code as well. So let me share that now. Application window. This brings us here.
-minute notification, Ody.
Okay, so it brings us here. So this is what it looks like. Remember what I showed you, the Webpack config. This is it here. And to run this, right, we just simply use the npm. Okay, so here we are running it. We are not using .NET to run it because we're running in a client-side JavaScript form. So first say npm install. And although you still need to have the .NET SDK installed, but that's not how you launch FABLE applications. Okay, good. It's installed. And then I just say npm start. So if you head over to your package.json, you'll notice that there is a script here that just runs the Webpack dev server. So I'll say npm start. When I run that, it will launch, yeah, on localhost 8080. Great. Let me go ahead and view that. Host 80. And I share this tab so you can see what that looks like. There we go. So as you can see, FABLE is running. You can click the button and it generates it multiple times. If we view page source, you can see that there's a link here to bundle.js. If we click it, you can see that this is the encrypted Webpack form. Now, the actual one you will use for so click this. There we go. So we've done the demo, and that now brings us to Elmish. So Elmish is essentially a single page web application framework. It leverages the Elm architecture. It uses React under the hood, and it is based on the model view update pattern, right? So it's a functional architecture. It's part of it's a kind of functional architecture for building UIs. And it is made up of three main functions. You have your init function, your update function, your view function. So the init function creates the model, which represents the state of the application, the visual state of the application. The update function takes an event, a mouse click, a timer triggering, and generates, or a message, and generates a new version of the UI of the model as well. And then it hands that over to the view, which renders the UI. So this is the Elm architecture in a nutshell. You have your init function generating the model. You can have subscriptions, so things like timers, things that fire on maybe on their own, or they're listening for external events. That's what this will be. But whatever makes any form of side effect or change that triggers a message that goes into the update function generates a new model. The view renders that new model. Clicking a button on the view is going to trigger a message back to the update function, and it renders a new model to the view. So that's the main loop itself. Okay. And yeah, it's a very neat architecture, and it's quite cool. So if you think of this like similar to what we did with the Giraffe, if you think of this as a building block, you can also compose multiple Elmish applications. So this building block is called an Elmish application. And then you can compose multiple Elmish applications together to form your actual application. So for example, your main web application could have an update function, and that update function calls the update function of the children, and those call the update functions of the grandchildren. Your init function of your main application will call the init function of the children. Your view function of the main application will call the view function of the children as well. So it's a very neat compositional application, and it's done in such a way that each application is standalone. So you could actually just lift and shift entire, maybe a login page, for example, from another application, and make very minimal changes to the application itself. It also supports, because it's using React behind the scenes, it also supports React components if you want to use that as well. So there's a vast library of React components that exist out there, and it allows you to just leverage that. So yeah, for more documentation, you can just head over to this URL for FABLE, and I will highly recommend the Elmish book done by Zaid Ajaj. Very lovely book. You should really check it out. It explains a lot. So yeah, putting it all together is what SafeStack is. It's just putting all these different pieces together, the server-side pieces, the client-side pieces together, and wrapping it all together with a nice bow on top. So you install it using the same .NET New -I save template that installs the save template, and then you can the documentation is at safestack.github. You get enterprise support as well. So if you want to use it in your company, and you need to be able to know that, okay, anytime you need support or whatever the case may be, that's done by Compositional IT. You can just go there and check them out. So demo time. I'm not going to do the whole SafeStack demo because the templates can be overwhelming, but I'm going to just show you a simple example of an application that we built using SafeStack. That's this application called Device Data, and let me show you what that looks like.
Here's your 5 minutes, Ody.
Okay, so I'm going to share this. Go to let me open a new tab. There we go. Share this. There we go. Good. So here I'm going to go to Device Data. what it is a database of sort for toxicologists, for mainly toxicologists, and it was built entirely with the safe stack. So this homepage you're looking at, everything is done with Giraffe and Swab and all of that. So what it allows you to do is it allows you to store data sets. We can pick a particular data set. We can pick this test file, and then this data set is just some CSV data. So even this table you're looking at is dynamically rendered using React and Elmish. And yeah, you can do things like see the structure of chemicals. So using these smiles, it renders the structure of the chemicals and stuff like that. You have searching, filtering, you have all kinds of aggregations. So for example, you can come here and see aggregations, others, whatever, right? Yeah, everything you see here is essentially done with the safe stack. So I'm showing this to show you that it's actually a battle-tested framework and platform, and you can use it to build whatever you want to do. And it's able to be this mature because it leverages a lot of the existing tools and infrastructure out there rather than trying to build from scratch. So yeah, I hope you were able to learn something, and I hope I was able to give like a high-level overview of the safe stack. If you want, you can always go back and you can definitely go back and let me see, hold on. So here we go. So yeah, yeah, you can definitely go back and look at all these things. This is my handle at odytrice on Twitter, and my YouTube channel is odytrice.com, youtube.com/odytrice. So thank you for attending this session with me, and I hope I was able to, get you at least interested in building F# applications with SafeStack. So thanks.
We have about 10 minutes for questions.
Yes.
I'm going to go by upvotes, but if you want to raise your hand, we can invite you on and you can ask your question directly instead of through chat. So it looks like I will wait just 1 second to see if I get a raised hand. I know not everybody's set up for being able to get the video.
Okay.
So the first question looks like we have is from Georgi, which is, how seamless is the data transfer from front end to back end? And he says, we do JS, TypeScript, Python clients towards C#, and there are some quirks around JSON.
Oh yeah, I think those quirks still exist. So the quirks in question are things like the date time, right? So date time representation and stuff like that. So the beauty of the safe stack is that you have, so for example, there is this native F# serializer called Thought. That's the name, THOTH. And what it essentially allows you to do is to make sure that you have the same, the serializer behaves exactly the same way, both on the client and on the server. So that handshake problems, those incompatibilities just go away because you are literally using the same code on both the client and the server. So it's actually quite seamless.
I don't see any raised hands still, so looks like Jacob asks, when building a middleware pipeline, do you need to think about and decide the order of the middleware?
Oh yes, absolutely, absolutely. You have to. It's not as critical as it sounds. You have to think of the order because the handovers matter. So, for example, if you put the authentication middleware after a particular middleware, then that middleware has no authentication on it, which may or may not be what you want. So the order actually does matter.
Enzo puts a comment saying, congratulations, nice work.
Thank you.
Luis asks, does FABLE interop with NPM modules?
Oh yeah, it does. It does. So it does, but the problem with that is calling those NPM modules. So the NPM module has to have FABLE bindings for it, for you to be able to call those things from JavaScript natively. However, the bindings themselves are not complicated to write. It's literally just a function. You put an annotation, then you can write your JavaScript integration to it. So with that in mind, you can call any NPM package. So I wish I could show an example of this, but it's not like you need some kind of special F# code written by the library authors to be able to call into it. You can just call it directly. You just need to write some type annotations to say, okay, anytime I call this function, this is what it should call in the NPM package, and that's it.
Robert asks, if you would like to go more into the direction of a single-page app, you do something similar to React and a pure REST API, what would be the pure F# way to do this?
Yeah, so the pure F# way to do this would be to use what they call it, would be to use Elmish, right? So Elmish gives you essentially everything that React doesn't give you, or rather everything that you get with things like Redux and stuff like that. So React just focuses on rendering to the DOM. Then every other thing in terms of constructing your application, sending HTTP requests, and so on and so forth, Elmish does that for you. So the F# way to do it would be to use Elmish, and then you can make calls. So there are two types of ways of making calls. There's something called FABLE remoting. I don't want to get into that. That's complicated. But what that allows you to do is just essentially see objects in your FABLE code and call those. And those objects have corresponding representations on the server as well. So you have this seamless communication between the client and the server. That's also possible using FABLE remoting. But most of the time, what you really want to do is just to send regular HTTP requests to your distant endpoint, to your Giraffe endpoint, and then handle it on the server.
Luis asks, when working with JavaScript modules on FABLE, does it provide any sort of type inference?
So like I answered before, right? So if you're using something that already has the FABLE bindings, then yes, you'll get full type inference, no questions asked. However, if you at that edge where you are communicating between, so at that glue, if you will, that you're using to gum the F# part to the JavaScript part, you could just write what the type signature is. So say, for example, I'm trying to call a function in I don't know, a browser API or whatever the case may be. I can write the call to the browser API, then put the actual annotation of the types I expect. Once you do it that way, then any code that depends on that glue would have type inference, attached to it as well.
So Jacob asked, does the compilation to JS happen when the server receives a request?
No, the compilation is done before the server is even triggered in the first place. So that compilation, you could even do it offline and just generate a JavaScript file, and that JavaScript file. So for example, if you're building containers, for example, at the point where you're building your container, that's where you do your compilation, and that's where you just stick that into the server-side folder. So there's no compilation going on as at the time the application is running. All that is done at build time or beforehand.
And then looks like Georgi asks it as another question. Can you decorate the handler with authorization policies like regular .NET controllers?
Yes, you can. So decorate is a fancy word, but you remember what I said about Legos, right? You can assemble different handlers together. So Giraffe comes with several built-in handlers for authentication, authorization, and stuff like that. So you can take an existing handler and then attach and combine it with an authorization handler, and then you now have authorization on your handlers. So that's pretty much how it's done. It's not really decoration per se, more like fused together.
And then I think you kind of touched on this one, but it's the last question. So Jing, if I'm pronouncing that right, asks, how easy is it to use NPM packages with FABLE?
Oh yeah, so like I said, it's very straightforward and simple. Most npm packages you need already have Fable binding. So once you just installed it from NuGet, there's even this tool, I can't remember the name of the tool, that installs the tool for you. It installs both the npm package and the binding for you automatically. But if the binding is not there, like I said, all you just simply need to do is write a simple file that it kind of reminds me of pinvoke. If you've ever done pinvoke in .NET, where you have a file that just says, these are the functions I expect, and these are the signature I expect the functions to have, and that's it. And then you can just call any npm package.
Well, thank you, Ody.